right. How was the intro that we had earlier? That was intentionally did, all right? We intentionally muted to see whether you guys are paying attention. Hi, anyway, you guys, congratulations for being here for the 5th edition of Marvex Power Talk, brought to you by Marvex 2021. Introduce myself again. I'm Jason, an MC for this evening, these sessions. Firstly, I know it's a busy week, and at this hour, I just want to congratulate you here for being in these sessions, because there's no better time than right now for all of us here to discuss what we're going to have for dinner today. Okay, I'm just kidding. But anyway, before we begin, let me know in the chat, how many of you here are attending this Marvex Power Talk for the first time? Type Y in the chat or type N, no, if you're attending this for the first time. Let me know. Type Y if you're attending first time, no, you've been here before with us, so that I know how many of you here been with us for the past many sessions. Okay, I know some of you guys are right now watching this. Maybe most of you are watching at home. Show me some love. Give me some of a like. Give me some of a heart shape in our Facebook, because you're all doing it in a way that I want to be able to engage with you. Give me likes. Give me thumbs up where you guys are watching it. Okay, before we begin today's sessions, we are going to be speaking a very interesting topic, a topic that all of us here been very excited about ever since this pandemic. And that topic is going to be healthy air is an investment or an expense. All right, and this topic is going to be a very interesting topic, because ever since the pandemic, many of the businesses will be thinking going into having a better IAQ or indoor air quality in full, which means that it's a very expensive investment. But actually, little people actually know that there are parts and technologies where implemented right, it will be much more cost effective and worth the investment in long run. So just want to ask our audience who are watching it live today, so let me know whether you think, to your point, whether investment in whether in the healthy air, do you think it's an investment or an expense? You can just type in the chat, typing investment or typing expense. Let us know what you guys think. For better indoor air quality, what do you guys think? Investments or an expense? Okay. So far, any comment coming in? All right, and maybe I see some are coming in already. But without further ado, let me share with you that Marvex Power Talk is a series of on-point discussions where leaders and experts converse and deliberate about the opportunities and challenges faced by the ever-growing, reshaping and uplifting of the air conditioning, mechanical ventilations, and refrigerations industry, in short, ACMV R. And this Power Talk is brought to you by Marvex 2021, which is the inaugural ACMV R business event for ASEAN, scheduled to take place from 1st to 4th December at Kuala Lumpur Convention Center. Marvex is jointly organized by MACRA and CIS, and this is going to be held concurrently with Engineer, where we strive towards becoming the premier event for the primary source of ACMV R stakeholders, while providing a unique platform for the growth and development of the industry in this region. We have prepared a short video to show you how you'll be able to leverage on this dedicated business event for your business. So let us play you this video.
Marvex will create a new milestone for MACA and the ACMV R Industry. We are working towards become the annual premium business and trade event. There will be an important date on the trade calendar for the industry within the ASEAN region.
Marvex is a platform that is driven by the industry for the industry. We look forward for this platform that provides our stakeholders with business networking opportunities.
Beside the all-day exhibition, there will be an industry conference, forums, and many more exciting highlights at Marvex.
Yes. We are as excited as you are with Marvex 2021. So be sure to stay until the end of these sessions to know how you'll be able to be part of this excitement. All right, back to today's sessions. Ladies and gentlemen, as I shared with you guys before, today we are going to be talking about healthy air. Is it an investment or expense? I see some of you here have posted, you guys are sharing, Aisha is sharing it's an investment, Chris CP is sharing investment, Mohammed saying investment with some expense, Yap is saying investment. Put your thought as well for those who are just tuning in. Let us know whether you think healthy air is it an investment or expense. Because today we have three very, very high-profile speakers who are with us here today to share with us whether it's going to be investment or an expense, or maybe both. Okay, so for today, by the end of these sessions, ladies and gentlemen, you'll be discovering three things. The first thing is what comprise a good standard of IAQ. Secondly, you also will discover what are the three challenges faced by the industry and how industry can potentially come together to overcome this. And lastly, what are the available solutions that can provide fresh air, yes, fresh air, without costly energy consumptions or even versus the conventional solutions in the market. If you guys have any questions that you'd like to direct to our panelists, feel free to type in your questions in the comment and we'll answer them at the end of these sessions. So our topic is going to be healthy air and investment or expense, and we are very honored to have three special guests as today's panelists. Firstly, allow me to invite we have Mr. Alvin Chan, Regional Application Consultant from the Southeast Asia region from Belimo Automation, Malaysia, Sdn Bhd. We also have Mr. Raymond Wong, General Manager, Segment and Product Asia of American Air Filter Manufacturing, Sdn Bhd. And lastly, we also have honor to have Architect Dr. Lim Chin Hao, Senior Research Fellow, Solar Energy Research Institute, in short, SERI, from the University Kebangsaan Malaysia, UKM. And today's session is moderated by Dr. Shazwin. And Dr. Shazwin is the Deputy Director of UTM Campus Sustainability Office from University Technology, Malaysia. Let me share a quick background to introduce our moderator for today's sessions. Dr. Shazwin obtained her degree from the Shiga University from Japan in year 2002 under Malaysia Look East Policy Program. She then received 5 years scholarship from the Ministry of Education, Culture, Sports, Science and Technology from Japan under the Global Environmental Leaders Program in Hiroshima University and obtained her Master in Science in year 2008 and PhD in Development Science in year 2011. She did her internship in Institute of Global Environmental Strategies, in short IGES, Japan, before return to Malaysia, and right now serve in the University Technology Malaysia at the Department of Water and Environmental Engineering, Civil Engineering School, Faculty of Engineering. Currently, she holds a position as Deputy Director of UTM Campus Sustainability Office. Her research interests include resource management, sustainable consumption, circular economy, and sustainability in higher education institutions. She has been awarded various international research grants with recent appointment in year 2021 from Climate and Clean Air Coalition's CCAC, United Nations Environment Programme, UNEP, to conduct a project in reducing short-lived climate pollutants in ASEAN countries. All right, ladies and gentlemen, without further ado, can you show me your love by giving me many, many likes, many, many love in the chat right now as we bring to you Dr. Shazwin on screen with us. Come on, bring me your love, bring me your light as we welcome Dr. Shazwin.
Hi, Jason. Thank you. Thank you for energetic opening and kind introduction.
No problem. Over to you, Dr. Shazwin.
Thank you, Jason. So a very good afternoon and a warm welcome to everyone who joined us in Facebook Live to the Marvex Power Talk series. I am Shazwin from University Technology Malaysia, and I will be your moderator for today's session. So this evening, as briefed by Jason, we will have a very interesting topic and very much relevant, especially now during the pandemic situation. healthy air and investment or expenses. And respond to Jason, what you call it, call out just now, I can see the comment moves to investment. So let's see at the end of the session whether you still stick to your opinion or our panels will shift your opinion a bit. Right, we will have 3 challenges that will be addressed today. So for the first challenge, since most of our AC system don't allow future upgrade to meet the new and ever-changing indoor air quality standard. So in future, how filtration system provider can work better with AC manufacturer to provide better solutions, and the needs to explore the possibility of increased longevity of AC usage for future upgrade and modification to meet future needs. And the second challenge is what is the current market acceptance of new approach to problem with unconventional solutions? The fact is most of the owner evaluates on cost versus benefits. So these intangible benefits from indoor air quality takes time to see, which is lead to deprioritize from project owner. So in future, how we can educate and raise awareness of the benefits of these new solutions. And last challenge that is, I think, is very much relevant is that we'll addressed by our panels today, aligned with current pandemic situation that has pushed the industry to think outside the box. Yeah, in order to address the concern of the COVID-19 spread in confined spaces, what are the technologies or strategies that can be integrated or combined with the existing air conditioning system in order to improve the indoor air quality during this pandemic? And how can the government assist the industry and building owner in order to improve ventilation and indoor air quality in building amid the pandemic situation? I am getting excited, and I hope all of you getting excited too to hear from sharing from our panelists today. So we have 3 invited specialists. We have Architect Dr. Lim Chin Hao, Senior Research Fellow from Solar Energy Research Institute from University Kebangsaan Malaysia. We also have Mr. Alvin Chan, Regional Application Consultant, Southeast Asia from Belimo Automation, Malaysia Sdn Bhd. And we have Mr. Raymond Wong, General Manager from Segment and Product Asia, American Air Filter Manufacturing Sdn Bhd. Right, for our audience in Facebook Live, if you have any question, please feel free to type your question at comments column, and please mention to whom your question is directed to, and we will be able to happy to attend you at the end of talk session later on. With that, let me introduce our first panelist for today's session. We have Architect Dr. Lim Chin Hao, who is currently a Senior Research Fellow at Surrey UKM. And Dr. Lim is both a professional architect and avid researcher in passive and low energy architecture. His research interests includes low energy architecture, building performance simulation, natural ventilation, building performance simulation, natural ventilation, indoor environmental quality, building insulation, as well as a building integrated photovoltaic system and solar assisted air conditioning system. In addition, he leads numerous collaborative research projects with universities and industries at national and international level. So ladies and gentlemen, without further ado, let me have an architect, Dr. Lim, to join me on screen.
Hi, Dr. Sashwin.
Hi, Dr. Lim. How
Good
are
afternoon.
you? Good
Yeah, fine,
afternoon.
thank you.
Thank you so
Thank
much.
you, thank you.
I believe the audience is eager to hear from you. So without further ado, I hand over the screen to you, Doctor.
Yeah, thank you for your kind introduction. Okay, I will start my presentation. Yeah. Okay, I think this afternoon I was given the opportunity to share, which is something that is relevant to current situation, which is actually our pandemic situation. I think after hopefully we were able to recover from this pandemic, and then life will proceed to a new norm. Therefore, I think the impact of ventilation is very important, especially on the indoor environment, as we know that this COVID-19 virus, or we call it SARS coronavirus 2, is able to transmit through airborne transmission. So therefore, we have to address this problem so that the future industry can able to adapt various of this technology and approach. All right, I think as we know, the SARS coronavirus 2 spread through droplets and also airborne. So for the airborne transmission, that's what we are concerned with now, because the airborne transmission actually involve the nuclei from the virus as small as less than 5 microns, which able to spread at a very long distance. Actually, according to research, is more than 10 meters in length. Yeah? And ventilation is the most important, especially in terms of mechanical or natural means. So a lot of research has found that higher ventilation is actually good, whether it's mechanical or a hybrid ventilation, so that we can dilute the contamination in the indoor air environment. So some researcher has recommended the use of natural ventilation for hospital buildings, which could include bigger windows, so that we can allow more fresh air to enter the indoor environment. Right. So the key here that we have to bear in mind that the ventilation rate, flow direction, and airflow pattern has to be the main parameters when consideration of the indoor air quality. Yeah. So the fresh air intake can come from either a mechanical system or, as I mentioned earlier, window opening. So the window opening allows a cross ventilation to come in and able to dilute and to take out the stale air out from the indoor environment to outside. So therefore, you can dilute the particles inside the indoor environment to make it the air more cleaner. In the research done by Chinese researchers, that they have actually concluded that 45% of the risk, you can get the risk infection of this airborne transmission if you have 1 hour of exposure. And secondly, in US, there's a research that stated that you can get 53% infection risk if it's the 2.5 hour exposure. So therefore, airflow direction and pattern is a substantial and very important criteria that we have to take into consideration when the direction of the air from the aircon diffuser or the split unit that you have is the blowing direction. If we have to avoid that the direction so that they can be scattered around and then less chances of exposure. All right, temperature and relative humidity is also one of the parameters, because coronavirus 2 survive longest in a lower temperature compared to higher temperature, and also lower humidity, which is less than 50%. Various researchers that has done and have published a lot of journal paper that says coronavirus is higher in dry indoor environment, which is less than 40%, than humid compared to humid environment, which is more than 80%. So the advantages of Malaysia is that we have high humidity most of the time, even to near saturation of RH, relative humidity. So therefore, we should take into consideration for this relative high humidity in our country to mitigate this spread of the virus. So the other one is the opening to wall ratio. That means how big is the opening to the wall that you have in the facade. So the higher is better, of course. The bigger wall window opening is better. So the best is actually to avoid this recirculation of air that what we call in the indoor environment. All right, that means the aircon doesn't have any fresh air intake. It keeps on recirculating the stale old air. So that's why we have a term called aged air. The longer the age, the worse it becomes for the what we call for the people to get infection. So the other one is a negative pressure. We can create negative pressure. Negative pressure actually can be created by using exhaust fan. to suck out the air from the indoor and then therefore create a negative pressure. So that it moves air from higher pressure to lower pressure. That means if there is any opening, the air will gush out into the indoor environment. So this is good. All right. So negative pressure is also been designed to be applied in this hospital, especially operating theater and so on and so forth. So they use this negative pressure to prevent certain spread of infection risk. So I wanted to highlight also a bit of this SARS coronavirus 2, especially if we look at the structure of this virus. There are four main structure, but I want to highlight the spike protein. A lot of people have been talking about spike protein. Even the Delta virus is where a different type of spike protein. But the spike protein in this coronavirus is very sensitive to higher indoor temperature, as mentioned earlier, and also able what we call to be destroyed by ultraviolet radiation and also extreme pH. So this spike protein is actually enable the virus to attach to the human cell and then travel around the body to infect you. So that is the thing that we have to take into consideration. So researchers estimate that every 1 degree Celsius increase from the temperature will lead to a decreased cumulative number of cases by 0.86. This is the data by the physiologists and clinical. Okay, the vulnerability of the SARS virus, according to the research, at 22 to 25 degree, it can able at also 40 to 50 humidity, so that they can actually flourish, but will lost when the temperature is raised to 38 and also 95% humidity, according to researcher. Okay, the other one technique or strategy that we can incorporate is actually called displacement ventilation. Displacement ventilation is allow the cool air to come in at the lower level, as you can see from the computational fluid dynamics, that cool air can come at the bottom level, and then as the cool air pick up the heat and through the buoyancy, the hot air will rises to the top and then will be exhaust out. So this is called the displacement ventilation, which can be incorporated in today's ventilation system. Okay, the next slide will be on natural ventilation strategy. Of course, we know that natural ventilation is free, almost FOC. So you can have what I call this cross ventilation, stack ventilation, and also wind-induced ventilation. All right, I will quickly jump into each one of them. Okay, cross ventilation, of course, you have two opposite side opening. The air will travel on one side and exit the other side. Stack ventilation is on buoyancy. Hot air, when it's heated up, it has buoyancy and it rises up, and then therefore you can actually exhaust it out. Okay. The other one is wind-induced. Wind-induced is when the wind is more than 0.5 meters per second. All right. So therefore, it creates a differential of pressure. So as you know, that wind travel from high pressure to low pressure, right? So that if you have any opening, that will induce further the airflow. All right. So ventilation rate is another one criteria, especially the air change per hour. According to the recommendation now, they are recommended around 12 air change per hour, actually by the CDC guideline. All right. So the another one that we can determine this to reduce the infection rate is by the CO2 concentration level as an indicator. So the more people, the more CO2 level higher, right? So we able to use this CO2 level to mitigate or to monitor the indoor environment. So if the CO2 level exceed beyond the standard level, therefore we must able to reduce the number of people in the certain environment. All right. So the other technology that we can actually look into is the HEPA filtration. I think our other speakers will talk more detail about this filtration system. I will not dwell in that longer. So this HEPA filter can be incorporated in our conventional air conditioning system, especially on the ACU side, to reduce this airborne transmission. And the other one, very interesting, is the UVC. Okay, UVC is actually one of the section of the ultraviolet radiation. Unfortunately, UVC actually been filtered out by the ozone layer as it travels from the sun to the earth. All right. So the only way for us to have this UVC is through artificial means, whether it's through light or LED. Now they have developed LED UVC, which can be incorporated easily into the air conditioning system, that you can use to eliminate this airborne virus. All right, this is the photo, just what I call illustration of the integration of this UVC into the ducting system. All right, so they have done a bit of research on this, and it has shown that that the UVC light able to reduce 99.7% of this airborne virus in 30 seconds. So therefore, it's quite effective. Right? All right. So with the conclusion, I just have to highlight few of the parameters so that you can take home with for consideration. Is actually a dilution of the indoor air through the ventilation rates and air exchange. The indoor opening size, window opening size, which must be considered as big as possible, and airflow direction and airflow pattern around the indoor environment, and also to reduce the occupancy time for exposure in the indoor environment, and also you can use CO2 level to do that, to monitor, and to increase the temperature as high as possible so that we can also reduce the spread of this virus. And also humidity, increase the humidity, and to utilize the air filtration technology that we have, and UV, such as HEPA filter, and also UVC light. All right, so I would like to suggest before we go to look into the WHO roadmap to improve and ensure good indoor ventilation in the context of COVID-19 as a guideline, so that later Malaysia will come out with our own guideline ventilation for the industry and also for the building owners to be used. Okay, with that, I would like to pass back the floor back to Dr. Shaswin. Thank you very much.
Thank you so much, Dr. Lim, for the insightful sharing.
Thank you, Dr. Shaswin.
I can already see some questions addressed to you here, but I'm afraid we have to keep them waiting. And we will have you back on screen for question and answer session later. Thank you again, Dr. Lim.
Thank you. Bye-bye.
Right, ladies and gentlemen, it is good to know, the ventilation can remove the contaminants and can actually reduce cross-infection in the air. Right, moving to the second panelist, we have Mr. Alvin Chan, who is a regional application consultant of Belimo Automation Malaysia Sdn Bhd, a subsidiary of Belimo Automation AG Switzerland. He is based in Malaysia and is responsible for the promotion of Belimo technical solutions in Southeast Asia. Mr. Alvin has 22 years working experience, all of which in HVAC and mainly in technical roles involved in various types of projects in Southeast Asia, China, Hong Kong, and Middle East. With that, let me bring Mr. Alvin Chan to the screen with me.
Hi, Dr. Shaswin. Good afternoon.
Hi, Mr. Alvin. Good afternoon. Great.
Yeah.
Right, let us hear your thought about the topic today.
Yes, we do.
Screen is yours.
Good day, everyone. I'm very glad to be here to be able to share with you the advantages of EPIV, which is an electronic pressure independent control valve. While we are focused on combating the COVID-19 pandemic with better IAQ, we must not forget our carbon footprint. I'll share with you how EPIV can save pumping energy, especially relevant now as you will need to run the air issue for longer periods to provide the target IAQ. For example, flushing before and after occupation, increased airflow for increased air change, building pressurization, or running the full system even at minimum occupation to provide the equivalent level of IAQ. EPIV's approach to pressure-independent control is entirely different to the mechanical PI solutions. Here, I'll highlight the 3 key advantages. EPIV is the first electronic pressure-independent control valve in the world, launched in 2010, and since then has good track record for being reliable and easy to use. it has one over many converts. The EPIV consists of an actuator, a control valve, which is the Belimo patented CCV, in use reliably around the world since 1999. It is able to control low flow even at high pressure drop accurately. The heart is the flow sensor. The function of a PI valve is to provide accurate flow control regardless of differential pressure. In order to do that simply, it is to measure the flow and then to use a controller at the actuator to provide the set flow. It is accurate to 5%, the best in the industry. How it works to control flow regardless of pressure change. The actual flow drops when differential pressure drops, but momentarily only, as the control valve will open to achieve set flow. Vice versa, if differential pressure increases, flow will increase, and then the valve will close to reduce the flow back to the set point. Simple, but much resource has been invested to realize this revolutionary valve control concept, and we continue to make it better with each new generation. The core in all our control valve is the CCV, or characterized control valve. It gets it from the characterizing disc, which is used to reduce the opening cross-section of the ball valve. With it, CCV can achieve equal percentage flow increase, which is the ideal flow curve for water-air heat exchangers like AHU coils. Because of the coil power curve, which is quick increase, the flow has to be opposite small increase to obtain linear power response to control signal. To get 20% power, 6% flow is needed. Therefore, 20% signal to the valve should obtain this same 6% flow. If without it, the flow will be 20% and the resultant power will be 45%. Simple and very reliable design. Advantage number 1, resistant to dirt in chill water. Because there's no mechanical pressure regulator, unlike mechanical PI valve, there's little to no chance of clogging. Besides, the CCV is self-cleaning. Every time it rotates, all the dirt on the surface and the seat of the valve is removed. No more issues with dirt in the water damaging the valve, period. This means reliable, energy-efficient operation for the entire life of the valve. Advantage number 2, mechanical PI valve requires a minimum control delta P to achieve PI mode. Below that, it is not PI. Not the same for EPIV. It can achieve the same part flows at much lower delta P. This means the pump can be optimized, resulting in lower initial investment and operation costs, because lower pump head equals less power, and that means lower energy bills. Next, we compare the selection process between mechanical PI and EPIV. Normally, mechanical PI valve will present increasing minimum control delta P as the flow increases, and this will mean increase in the pump head requirement. The energy used by the pump for mechanical PI can be saved with EPIV. Advantage number 3, it's so easy to set up and verify the operation with the ZTH2. You can also connect a laptop to a laptop for setting up and testing, trending data, and to download the data for later analysis. If connected to BMS by backnet, all testing and setting changes can be effected from BMS workstation. You never need to go to each AHU. June this year, we just launched the latest generation of EPIV, now with even more user-friendly features like standard backnet support, glycol monitoring and compensation. Setting it up is made even easier, now just with Belimo phone app. Belimo is a field device specialist since 1975, with the first direct drive actuator, and have always held true to our company DNA we call CSIM, which stands for Comfort, Energy, Safety, Installation, and Maintenance, which guides our product development process to address real-world problems. We have a complete range of air damper actuators, VAV, valves, sensors for the entire HVAC system. Together, they play a big role in energy efficiency, though often seen as small items in the makeup of the system, which explains our tagline, small devices, big impact. Please contact us if you'd like to learn more. That's all from me. And thank you very much for your time. I hand the stage back to you, Dr. Shaswin.
Thank you so much, Mr. Alvin. I guess now we learned that there's an option offered in market to maximize our energy saving. We will get back to you, Mr. Alvin, during question and answer session later.
Thank you.
Thank you. Right, for our audience who join us in Facebook Live, for those who want the presentation slide, it would be good if you can drop us a PM with some details with your name, company name, email and contact number. So the secretary will get back to you with the information soon. Again, feel free to ask any question and comment in comment section for our panelists today, so we can come back to you shortly during question and answer session. Now, for our third and final panelist, Mr. Raymond Wong. Mr. Raymond is Asian Segment and Product General Manager of American Air Filter Manufacturing Sdn Bhd. He has more than 15 years of experience in the air filtration business. He is also one of the company's director in the Singapore office. He is competent in clean room and mechanical services, IAQ, risk management, and also a certified construction safety project manager, as well as an experienced certified trainer. Ladies and gentlemen, let's welcome Mr. Raymond on screen with me.
Hello, Dr. Jasmine.
Hi, Mr. Raymond. How are you?
Hey, fine. I'm okay.
Great. Are you ready to share with your audience today?
Yep, sure. I'm not sure they can see my screen.
Yeah.
Okay. So, shall I proceed, Dr. Jasmine?
Please, Mr. Raymond, go ahead.
Okay. Thank you, Dr. Jasmine. Good afternoon, everyone. Thanks, Marvex, for having us here to share why fresh air is not expensive after all. Okay, today we're going to cover the topics on agenda, you call it, the importance of the clean air, the importance facts of the air leakages, and how technologies can help us. Okay, why fresh air is important to us. Okay, we consume 1 kg of foods per day. We drink 2 to 3 kgs of water per day. However, we inhale about 15 to 20 kgs of air per day, right? And especially as the current experience that we have during pandemic, we will stay indoor more than 95% of our time. All right, so that's a reason, one of the reasons why fresh air is very important. However, we also cannot neglect the presence of the gases in the air too, like VOC, H2S, and so on. Right. So we need to acknowledge that smoke is particles. So whenever you see something is burning, you have to move away to the safety distance. Otherwise, your lung will be your filters, right? Everything will inhale in. Okay. So that's another reason why if the air that we're breathing in is not clean, our respiratory systems will be at risk. Okay. according to the ISO 16890 filter rating, okay, based on the 3 particle size, PM10, PM2.5, and PM1, okay. And now we like to look at the likely regions of deposit, okay. Like, for example, the PM10s, how they enter to our respiratory systems, okay. For PM10, you can see they will go in through the nose, okay, and then they will start at the trachea. For PM2.5, it will go much deeper. It will go all the way to our bronchioles, okay. And the most dangerous one is a PM1, okay. It will go all the way to our alveoli, okay. So fresh air is really important to us, okay. The classifications of the ISO 16890 is oriented towards the regions of deposit in the human lung, okay. Here is one of the very typical examples that we're going to share with you. Okay, this is the old problems. No cleaning of the ventilation will be short life. Okay, this is a very common sight. I can trust we can share to you in the market right now. So we need to keep the system clean in order to keep the design airflows, which influence the temperature and the RH, reduce the indoor contaminants from humans, okay, building materials and equipment. We need to keep the efficiency of the equipment, okay, it's like the fan, the heating, and the cooling coil, etc. Keep the indoor surfaces clean, avoid microorganisms in the systems, and to remove the outdoor contaminants. Okay, this is the most common problems, but it is critical than ever. Why? Because this is pandemic that what everyone is experiencing. See, let's take a look on the impact, okay. With 1 mm gap, okay, the installation of a F9 filters can reduce its efficiency to F8. That means it will downgrade 1 grade lower the performance. Okay, what is the impact of 10 mm gaps? It can drop 2 grades of a G4 filters rated under the EN779 to G1. That means it will drop 2 grade lower. Okay, the higher the efficiency of a filters typically is having a higher resistance. Therefore, bypassing in those filter is more adversely affected. As everyone understand, the air is very smart. Okay, if you pass through the filter, there is a resistance, right? So if there's a gap of 10 mm, of course the air will be traveling to the least resistant, right? It will not travel through the filter here. It will travel through here, smart way. Okay. There isn't any strict or right answer to having a good indoor air quality. And ideal solutions for a building will vary across the building types and geographic locations. Focus on the air filtration, ventilation, temperature, and humidity control, and the potential supplementary air cleaning technologies. Okay, here is the industrial regulatory guideline, okay, by X-ray and by CDC, Center for Disease Controls and Preventions. Both of them also recognize recommend, okay, to upgrade your existing filters to at least to the minimum of MER13 or F7s, okay, as they are efficient at capturing airborne viruses. Okay, so even CDC have the same recommendation, minimums, MER13 or F7. Okay, if your system is allowed, okay, F8 or MER14 is preferred. Okay, as the industrial or the air filtration is moving from occupant comforts to life safety. Okay, there is a proactive action which we can take. Okay, the recommended approach in solving the IQ or the contaminations problem. Okay, first we need to really understand or identify the source. Okay, only when you identify source, then you can implement all these strategies. Okay, first, after identification, you use administrative control. Okay, if it's not effective, you use engineering control. Okay, if it's not so good, substitutions. Okay, and the best is to, if you can, to eliminate them, right? So if you're in doubt, working on the air filtration is the #1 initiative action you should prioritize first. Okay, air filtration versus the virus. Okay, air filtration captured virus at size base, okay, what we call respiratory droplets. Virus always enclose or they piggyback on something so that when they're floating in the air, that's what we call mixing. Okay, moving as a form of aerosol is called aerosolized particle. During coughing, the droplets are 10 times larger, over 10 microns. For the safe droplets, HEPA filter with H14 efficiency with EFRM media is a good recommendation. Okay, now we take a look at how technology can help. Okay, this is a typical installations of the commercial building. We would like to bring our focus here is the filtration area is always a limited space, and there is always a challenging challenges, okay, to upgrade or to add in one more grade, okay, or to upgrade the filter itself because the fan static, okay, has a limitations, right? So what happens if you cannot do anything here? The impact is, given an air change of 6, okay, assuming the living virus have 3 hours shelf life, okay, so you have a 6 air change and 3, the shelf life of the virus is 3 hours. So mixed with the other droplets can circulate 6 or more times within the HVAC system. So in other words, you have 18 chances or 18 times of chances that you will get infected. So what do you need to do? So we need to either implement a supplementary equipment, okay, to improve the indoor air qualities or to increase the air change rate. Okay, here's a product we call AstroPure series. Okay, let's take a look on the product core value first before I go into the explain the airflows schematic. Okay, it's a standalone mobile suitable indoor and outdoor applications. Of course, outdoor you need to be sheltered, right? Okay, designed with the combinations of HEPA filters, gas phase, and optional UV germicidal irritation. In short, you call UVGI. Okay, designed with variable fan speed, insulate double wall housing construction, provide whisper quiet operation, easy installation, operation and maintenance, plug and play design concept, supplementary, which not required to incorporate with any of the existing equipment to work. 100% risk-free test on the housing, new membrane media, EPDFE or EFRM. Okay, it will be installed in the HEPA filters. 100% scan test HEPA filters complete with scanner report. Okay, basically is you have a 30 amp plug, you plug it in, you turn it on, the air will be sucking it through here, go through the pre-filters and pass through the UVC, okay, and it will be filtered through the H14 EFRM before it being delivered back to the occupant zone. And this unit is totally standalone, mobile, supplementary. Okay, this is the most important part, okay, on the filter itself is filter efficiency. Okay, let's take a look what are they. Fractional efficiency curve for the EPDFE and EFRM. There's a new membrane we're talking about. Okay, at the MPPS level, most penetrating particle size, okay, comparing to the traditional microglass performance. Okay, the blue curve here is representing the traditional microglass, fiberglass media. Say at MPPS level, okay, you can capture 0.13 microns. Okay, where else you can see this red curve here is the MPPS of the EPDFE, and you can capture 0.07, right? So in terms of the performance, the new membrane media have a much better performance or much better efficiency compared to the traditional fiberglass. Okay, and due to this COVID-19, you can see here the size. Okay, after the conversion, okay, it will be 0.06 micron and 0.14 microns. Okay, that is new. So whenever they are in airborne, okay, they piggyback on some things, the size are much bigger. Okay. Okay, here we like to show you how the AstroPure series, okay, can turn, or you want to make turn the rooms into a negative pressure. Okay, it can be done by having the drawing in the polluted air. Okay, have it filtered through HEPA filters over here before it being released into the environment. Okay, so then you will have a negative pressure here. Okay, this is another installations how we can bring in fresh air to provide the room to turn the room into a positive pressure. Okay, we're taking the fresh air, we clean it with the HEPA filters before delivered into the occupant zone. Okay, or you would like to have it in the recirculation mode, okay, without incorporating any of this your aircon system, your existing aircon system. So basically, what you need to do is you're sucking in the polluted air, okay, filter through the HEPA filter before it being returned back into the occupant zone. Okay, so that is vertical flow, similar to a recirculation, but in a vertical flow manner. Okay, especially this is very good for the meeting rooms. Okay, same thing, it will not incorporate into the existing system. Okay, here I would like to show you IoT also play a very important part. The product that we have called Sensor 360, we will turn the invincible visible. Okay, what the magic this Sensor 360 can do? It comes with the pressure sensors and particle sensor. The pressure sensors is to monitor your filter bank, the resistance. The particle sensor is to capture the upstream particles and the downstream particles, and will give you the filter efficiency. Right, the data will be collected. Okay, it will push to the gateway, and the gateway will push to the cloud, and the cloud will push the user through the mobile or the desktop. Okay, reflecting the information like current pressure drops, optimized change point, live remaining, TOC status, okay, total cost status, live remaining consumed, and the energy usage, okay, while they're sitting comfortably in their office. Okay, on top of that, we still have the total cost ownership diagnosis software with the data captured by Sensor 360. We can input here into them. Okay, at this blue column, we can see here, this is the filter investment cost. This is the energy cost, and this is the labor cost. Okay, total, we have 5 factors that taken into impact on this the total cost of ownership. That means your filter investment cost, energy cost, cleaning cost, replacement cost, and disposable cost. All these 5 factors will conclude the TCOD. Okay. The last point here is this TCOD will have a decision point mix or suggest to you at the optimum points that is the best and most economical way. Okay, when do you need to replace your filters? Okay, the black line here is the total annual cost. This is your energy cost, and this is your filter cost. Okay, with the industrial regulatory guideline and the IoT technology plus the software in place, we will say fresh air is not expensive after all. Okay, and the key takeaway for today is air is essential for life. That's why we need to understand the underlying reason and the impact of maintaining clean air through the industrial regulatory guideline, incorporating with guiding principle of bringing clean air to life, making the air healthier for everyone, protecting people, equipment, and our businesses. Okay, with that, we'll hand over to Dr. Zazwin.
Thank you. Thank you, Mr. Raymond.
You're welcome, Dr. Zazwin.
So I think it's very insightful sharing on what air filtration technology got to offer. Now we have heard from all these 3 panelists addressing all the 3 main challenges that we have been highlighted earlier. We shall now move on to the discussion forum and tackle some questions from the audience as well as some questions from me. Before that, maybe we can invite the other 2 panelists to join me on screen. Welcome back, Architect Dr. Lim and Mr. Elvin.
Thank you.
Right. So let me go to the question. I guess maybe to Architect Dr. Lim first. during this pandemic, I think the concern is quite high. So what are the technologies or strategies that can be integrated or combined with the existing air conditioning system in order to improve the indoor air quality? Dr. Lin. Sorry, Dr. Lin, I think you are muted. Maybe you can unmute yourself. Okay, you're good now.
Okay. Can you hear me?
Yes, please.
Okay. I think there are many strategies. I would like to separate it into two. One, of course, is using strategy. The other one, of course, is technology. Technology. Strategy means like, for instance, displacement ventilation technique is the strategy that can be incorporated for the building managers and to bring in the fresh air into the indoor environment, right? And flushing and purging the stale air out. That is one way of looking at it. And the other way is through like a CO2 sensor that can be incorporated into the indoor environment to monitor the occupancy inside a confined environment. So if the confined environment has a very high CO2 level, therefore we can know that maybe there is no social distancing within that confined environment. So therefore we can bring in the fresh air, we can reduce the occupancy of the environment. All right. So the other one is actually integrating technology into the ACMV system, such as maybe like what I mentioned earlier in my presentation, the UVC radiation or other type of HEPA filtration system, and maybe to what we call to explore other new technology such as nano silver technology. There are research on this area, especially together with the Unity. Now this is one of the technology that they can actually incorporate into the filtration system to able to kill the virus. Like other technology like photocatalytic oxidation, or sometimes known as the PCO, is one of the very promising and energy efficient air purification technique that it will able to break down the wide range of pollutants into non-toxic byproduct like H2O and so on and so forth. This very efficient way of removing these pollutants might be the side product is actually like this releasing ozone that people are still in concern with this product. But they are substituting it with titanium dioxide, the OX2, which is can able to oxidize, is oxidation agent, which is widely used. So the other one very promising in the research level, and maybe could be in the future, is called the SOP filters, or the solid oxygen purification. It's a self-disinfecting filters that have potential to deactivate the aerosol viruses. This solid oxygen purification system is made of compound like alkali metal oxide, which convert air pollutants into oxygen when they come into contact. So the advantage of this SOP is that it has a self-cleaning capabilities. So therefore, like Malaysian, kita punya maintenance is very poor. So this technology is actually very good for Malaysian context. The SOP filter can have a self-cleaning capabilities, and it can be integrated into this ACMV system. Based on research, I think they have published this in many research papers, and it has observed that it has 99.8% efficiency in deactivating aerosol viruses. So these are all technology that perhaps the industry can look into. All right. Thank you.
Thank you, Dr. Lim. I think it's good to know there's a already product that market ready and more to come in innovation stages. So it's very promising for the market. I also have one question from Mr. Alvin. From a non-technical background, ordinary consumer like me, if I want to do this cost-benefit analysis, if I want to consider EPIV for my ASU, how do I do this? Is there any calculator?
Yes, sure. You can use our savings estimator. It's available in our website. So what you do is you just need to key chiller plant information, and that's it. It will calculate to you calculate out what is the savings.
Okay.
Besides
So
AHU, EPIV can be used for FCU too, especially FCU with ECM fans, where modulating chill water flow is important to ensure comfort and good delta T.
okay. As long as we
Okay.
know about our product, the details and characteristics of our product, so we can just key in your stimulator, is it?
Yes, that's right. The information is easily available from the facility manager or the designers or the consultants.
Okay, thank you.
Yeah.
And can I have one for Mr. Raymond? In your slide just now, you do mention about ePTFE and EFRM. Can you share us more about these benefits?
Okay, sure. Okay, PTFE or EFRM is a new membrane media that available from AAF with the following features or benefit. Okay, it's first we started off with low initial resistance, or we call it pressure drops, as high as up to 50% compared to traditional fiberglass. Okay, for example, your fiberglass initial is 100. Okay, for PTFE or the new membrane, okay, it will be started at 50 Pascal. Okay, on top of that, it had 84 times of higher tensile strength. That means if you accidentally touch the media, okay, it's fine. Or you can even brush your fingers against the media. It's still perfect. It was still working okay. Okay, almost zero outgassing. And it's hydrophobic. So if it accidentally drops the water on the media, okay, it will flow away. Okay, it will not be absorbed, hydrophobic. And a great chemical resistance, especially to the acid, okay, resistance. And having a much higher efficiency, okay, under the most penetrating particle size of 0.07, much more stringent performance than the traditional glass. Okay, and the most important is the market during the commission is PAO aerosol compatible. Okay.
Oh.
Yep.
Thank you for the explanation.
You're welcome.
I will now pick up some questions from our audience in Facebook. I think this is for Mr. Alvin of Bellimo. It's from Mr. Danny Chung of Makra. Any water balance required?
No, when you use a PICV or pressure independent control valve, there's no balancing required. The selection for the valve, you just need to refer to the ASU datasheet flow rate, and then from there you select the size based on the flow rate, and that's it. And you must set the flow rate into the EPIV, and after you just automatically control the flow based on the flow set point from the controller.
Okay.
Yeah.
And when we still at you, Mr. Alvin, we have one more from Mr. Muhammad Sirun. Could you elaborate more on how APICV can save more energy compared to PEC PICV?
Yes, one of the graphs which I showed, it tells you the differential pressure requirement for mechanical PI valve and for EPIV. So for mechanical PI valve, there is a range of differential pressure that you must prescribe. So example, let's say it's 5 to 50 psi or 35 to 350 kPa. You must provide this pressure for the valve for it to function in PI mode. So the minimum pressure, the 5 psi, must be provided by that pump. But for EPIV, you do not need that minimum pressure. So therefore saving you energy in terms of operation of the pump, because the pump head will be lower.
Okay, thank you.
Thanks.
So can I have one more question? This is for Miss Dr. Lim. This is from Mr. Tan, Mr. Peter Tan. How does one prevent recirculate contaminated air?
Yes, I think the recirculation of air is normally happens when if you are in a split unit system, air conditioning system, whereby there is no intake of fresh air. So if that happens, that we might have to open some window to allow fresh air in. That is the easiest way out lah. So the other thing is to incorporate filtration system, portable HEPA filtration system, which can be easily obtained from the market lah. So if let's say you're talking about bigger air conditioning system, I think there are several type of air conditioning system that we have to look into. They have a certain percentage of fresh air intake, so that this fresh air will able to dilute the indoor air of a confined space. So the dilution process will then what called minimize the infection rates. Okay.
Okay, thank you. So maybe I have one for Mr. Raymond. Is there any available wireless device that can capture particle concentration in terms of PM1, PM2.5, and PM10 and send the data to the user via mobile apps? We depend too much on our mobile apps. So now I have to ask this question. Sorry.
Sure. Yeah, we do have a wonderful device. We call it Sensor 360, and we have a tagline called make the invincible visible. So what it do is the sensor will pick up the dust concentration, okay, that we used to deploy to what I call to measure the filter efficiency, or how good the filter is performing when after they install into the equipment like ASU, right? So we have two sensors. One will be deployed at the upstream, and one will be deployed with the downstreams, right? So the differences then is the performance of the filters. Okay, with that data captured, it will go through and then we will push through the apps that to the mobile phone that the user is using. So with that conveniency, that means the facility guy or whoever uses devices, they do not need a huge manpower to deploy the guy to the site every morning to check the condition of the filters or the equipment. With the comfort on the desktop or while they are on the bus or traveling, so they can just click and what I call this to read the data. Or in case if there's any fault, they can immediately call back their control room to activate some guy to take a look. So that will be a good practice for the industry.
That is very convenient, I believe.
Yes.
Thank you. And while we at you, I think we have one question from Miss Naura Jasmine. I would like to ask a question to Mr. Raymond Wong from EAF. Is there any filter that can filter up the current coronavirus that can directly be installed to the existing issue? Due to space constraint, as we don't have any location to install any new device in the office building, can you recommend any filter product? Meaning that they don't have enough space to install new device. So is there any options to filter on the existing issue?
Okay. Understood. Okay, I think the question got two parts. One part is any product to handle coronavirus, and then the other part is they don't have sufficient space to install or to updo some modifications. Okay. The first part is we do have products that can what they call inactivate the coronavirus family groups. Okay, the product name was called Vanish. Okay, so what they do is they will they have the capacity. Okay, once they trap the viruses, they will inactivate the viruses. Okay, so we have one products of that. Okay, then that also come with the test reports from Japan. So that is quite effective, and we have been selling that in the region for quite some time now. Okay. The other one, okay, the question is the space. Okay, let's say you don't have much space to upgrade or do any modification of your existing systems. So always look out for the supplementary types. Okay, like air purifier, which we shared just now. Okay, the air purifier itself, we have the flexibility to configure the needs to the needs of the customer. Okay, for this case, I believe he's looking at, you must have the particle efficiency as well as the capability to inactivate the virus as well. So we do have the right solutions, but in order to give them the best solution, we need more information to understand. What is the area they're going to cover? Because that will become the size configurations. Yep, for the selection. Do contact us. We can help you further from there. Yep.
Yes, I think Miss Nora, maybe that's a chance for you to visit the Marvex Stocks session later on as well. Yeah, one-to-one consultation. So I have a question from Miss Eugene Tang. I think this is for Mr. Alvin. Can the EPIV and flow meter valve be combined? And what is the benefit to separate these two valves?
Actually, the EPIV is a combination of the flow sensor and the CCV, the control valve. They come as one product or one product code. So then I guess you are happy to hear that answer. Okay. So, all right. But if for situations where you need to separate them due to space constraint, actually you can also, yeah. So you can separate them, but it will still work just as one product. Yeah.
Right. So one next question: what if the flow sensor fails?
If the flow sensor fails, the control logic will automatically go back to traditional control, where the signal controls the valve position. If it's EPIV, the signal controls the flow. Okay. So until you get the replacement, it will still work just as a valve, but as a traditional valve. So Belimo gives a 5 years warranty and will be happy to replace the entire valve.
All right. So no worries.
No worries.
Right. We have one more question from when we got to Dr. Lim. Hi, Dr. Lim. Good day to you. I would like to ask in Malaysia, do we have a specific indoor air quality health standard for CO2, PM 2.5, etc., that showed the quality whether in excellent or bad condition?
I think for Malaysia, we have already a standard by Department of Occupational Safety and Health, DOSH. DOSH already have an industrial code of practice for indoor air quality 2010. However, but because of this pandemic situation, I believe the government already come out with a special guideline, maybe some improvisation or improvement for this old code 2010 code. So the government want to improve that to suit our current situation. For instance, maybe last time is 6 air exchange, but they will maybe increase it to 12 air exchange because of this coronavirus. But if we want to talk about Malaysian standard, yes, we have, but it's 2010, but need to be improved.
Thank you.
Okay.
Thank you. So I think maybe we have one more. I think this is a general question, so I will just throw to all the panels from Eugene Tang. How do we know how bad is the indoor air quality before it is too late? Okay. Any of the panels before it's too late? Anybody want to pick up?
Okay, maybe I can share the information, right? Okay, yeah, I think the question is, how do we know how bad is the indoor air quality? Okay, I'm not sure which direction it's coming from, but basically you can do an air sampling test. That's called an indoor air quality test. So from the test, you based on what Dr. Lin had mentioned, there's a guideline. So you based on the guideline, then you can know whether your indoor air quality is good or bad. Okay. First, you need to do the air sampling first, because without getting the samples from the air, our naked eyes won't able to tell, right? Or you can deploy our sensor 360. It will instantly tell you the invisible become visible. What is the concentration in your indoor environment? Yeah.
Thank you. Right,
Okay,
thank you. I think this is the last question from Facebook, from Yuzwan Zaino. Hi, I would like to ask Dr. Lim, if a general space need to convert into a quarantine facilities or emergency hospital, what factors or improvement need to be done for the ACMV system to serve for patient management and infectious control purposes during this pandemic? Wow, interesting question.
Okay, sorry. My mic is actually in mute condition. Okay, can you hear me now?
Yes, yes. Okay.
Okay, I think regarding the question about this patient, right, in a hospital condition, right?
Yes.
Yeah, I think the currently the indoor air quality, especially in the hospitals, the government now is monitoring quite closely the quality of the indoor air quality. But currently they also in I would say that the healthcare is in the verge of collapsing with all the number of cases arising. I think the best way for us to look into is actually to allow more fresh air. That is the very how to say very direct way of treating the condition of the indoor environment without having to spend a lot of money. And this is because I know I work on with a certain hospital, certain government hospital in Penang, dealing with this COVID patient. Those of the wards those days are air conditioned, air conditioned. But currently they have shut down all the air conditioning system. Now they use windows to open up to allow all fresh air to come in. So that is the most immediate and direct way of handling this current pandemic situation. You're not able to spend a lot of money, right? This is a very fast way to do that. So I hope that will answer the question.
Yes, I think. Thank you. I think that's a good question that come from the audience, and it's a good way to wrap up the session. Right. I think that's all that we can cover. We exceeded the time actually, but well, the sharing session is so interesting, and now we have discovered the technological advancement and affordability in the ACMV and R industry, and understanding how it all works and finding out how investing in this product and technologies can be economical and more efficient in the long run. So the response that we received at the early stage of Jason's question on investment, I think everybody got it right. Right. Before we end this webinar session, can we have our panelists to give us the number one key takeaway from for all of our audience in line with today's topic? So maybe I should start with Architect Dr. Lee.
Okay, I think a key takeaway I would like to bring forward is actually employing preventive measure to mitigate this indoor air quality. That we can actually killing these two birds with one stone. One is reducing the airborne this infection of COVID-19 virus, and also to fight against the climate change. So if you deploying a technology that able to do both, that will be the best for you, which also accomplishing the sustainable goals or the SDG that the government is promoting. All right. Thank you.
Thank you. Thank you, Dr. Lim. Anything to add there, Mr. Alvin?
Yeah, I think while we place a lot of emphasis on IQ, which is good, we must not forget about sustainability. Yeah, thank you.
Thank you. Let's hear one more takeaway key from Mr. Raymond.
Yep, sure. I think I have repeat that. So maybe it's good that we go through again, because air is essential for life. Right? That's why we need to really understand the impact and the underlying reason for doing it. Right? So to make the air healthier for everyone, protect the peoples, the equipments, and our businesses.
Right. Thank you. With that, I would like to take this opportunity to say big thank you to all the three panelists, Dr. Lim, Mr. Raymond, and Mr. Alvin, for sharing your thoughts and knowledge in this Power Talk. And on behalf of the panelists, I would also like to extend our appreciation to Event Secretariat for providing us this platform today, and I'm personally very happy to be able to contribute. As a last note to our audience, congratulations on successfully staying until the end of today's Marvelous Power Talk. And when you would like to discover how to be part of the business event in this Power Talk series, there is a posted link in the comment box. So do click on the link to schedule an appointment with Marvex's marketing team for further discussion. And finally, do stay tuned for next Power Talk session. Stay safe and take care. Bye-bye.
Bye-bye, everyone. Thanks.
Bye,
Bye-bye.
everyone.